Let us learn how to draw the circumcircle for a triangle and understand what are the properties of circles. So here triangle ABC is acute angled triangle. ABC, each angle is acute angle. So the circumcircle is the circle which passes through all the three vertices of the triangle. And to draw a circumcircle, first we have to see how to draw the perpendicular bisectors of each side of the triangle. Then, wherever these bisectors meet, that becomes the center for the circle. And this center is specifically having the name circumcenter. So, let me begin with first bisecting BC, the side BC, taking more than half and drawing arc. I am just drawing part of the circle, not full circle is drawn. So one bisector is ready. So this is a perpendicular bisector of BC. Now let me draw perpendicular bisector of AC with more than half radius. Draw the arc. And bisector of AC is done. Now the third one, bisecting the side AB. Actually bisecting two sides enough, but let us continue to draw the three bisectors. And here is the bisector, third bisector. And we can see all the bisectors, three bisectors meet at a point. And that particular point is called the circumcenter. Let me name this as O. And now, from this circumcenter O, the distance to the vertex, any of the vertex, is called circumradius. So we can draw a circle. So the circumcircle is drawn. Let me just highlight this. As we are going to learn certain properties of the circles using this circumcircle concept. So being an acute angled triangle, the center circumcenter is positioned inside or in the interior of the triangle. Let me do the same for obtuse angled triangle now. Let us see how is it. Bisecting QR, taking more than half of the QR, and we are drawing the bisector. And now let me bisect PR, more than half of PR, and draw arcs. And now draw the bisector. And bisector of PQ is to be drawn now, more than half. Accuracy counts. Let me extend the first bisector of QR. Yes, all the three bisectors meet at O. Now we can observe the circumcenter O is equidistant from P. P, Q as well as R. So that is the circumradius. And let us draw the circle. Using this circumradius, we are drawing the circle. So the position of the circumcenter is in the exterior of the triangle. Now, let us check how this will be for a right angled triangle. More than half. So one of the bisector is drawn. And bisecting the other side ln. Bisecting the third side, hypotenuse, the longest side, taking more than half of mn. We should be observant while doing so, as the arcs are overlapping previous arc. So we can see here all the bisectors, three bisectors, they are meeting at the midpoint of mn. So mn and n each equidistant from the circumcenter O. You need to mark this circumcenter O, and the hypotenuse midpoint is the circumcenter. Radius is nothing but half of hypotenuse. So this is how it is. So O is here. So if we observe here, certain important properties of circles are visualized. Let us do it one by one carefully. So this is for the right angle triangle, and for the obtuse angle triangle, as we can see, the circle is large and major part of the circle is having its area outside. The region of the circle, circular region, is outside. That is a special observation during this process of drawing circumcircle for obtuse triangle. I am not doing anything as such, I am just highlighting the circle now. Let us list now one by one the properties of circle which are connected to the circumcircle. Consider the chords AC, BC and AB. Chords are having their bisectors passing through the center. So first property is the bisectors of the chords in a circle pass through the center. And the converse. any perpendicular drawn to any chord from the center, any perpendicular drawn will be intersecting the chord at its midpoint, that is the converse. Second property, we can see here the obtuse angled triangle. Even in this we could see here the chord getting bisected passing through the center of the circle, whichever is the position of the chord. And even the right angle triangle is observing the same property what we have just now written. Let me measure this angle. This is an equilateral triangle. We can see here the angle is 60. So we can observe here 60-degree angle, and in case the two radii are drawn, this is the circumradius, and let me draw that so that it is one of the property which we are considering now is evident. So this is equally divided, and that is 120. So we can observe the central angle theorem. Angle AOB is 120, and ACB is 60. AOB is 120, ACB is 60. This is telling us the arc AB, arc or the chord AB, angle subtended by the chord AB at the point C, that is at a point on the circle, is half of the angle created by the same at the center, or the central angle is double when compared to the angle created at subtended at any other part of the circle. So this is illustration of central angle theorem. So one more property is central angle theorem. The same can be understood in the other way also, as we already have checked during that bisection process. So this angle is 240, and any angle subtended here will be 120, and it will be creating the reflex part. Okay, now let us see how this illustrates any other property. I am observing here right angle triangle evidently gives us example of property of angle in the semicircle. Angle in the, so right angle triangle, observe the right angle triangle here. This is the right angle triangle for which circumcircle is drawn. We can see 90-degree angle here, and it is the semicircle part. So any right angle triangle will have its circumcenter at the midpoint of the hypotenuse, and in such a case the semicircle will hold or enclose one right angled triangle, and the angle subtended at the semicircle is always 90 degree, all the angles. So we can write it as angle in the semicircle is a right angle, and that measures 90 degrees. It is also illustrating one more property, that equal chords AB is equal to BC is equal to AC in this first acute angle triangle whichever we have drawn, and equal chords subtend equal angles at the center. So we can observe here BC is creating 120 degree at the center, AC is also creating 120 degree at the center, and AB also is creating 120 degree at the center. So we can write another property, equal chords subtend equal angles at the center.